Kudos, cheers, and welcome. All right, so I kind of got I cheated. I got a head start on this project. All right, we are building a 4x8 sheet metal table. It's for an HVAC company. Same guys, same couple of companies we've been doing work for forever. They're related, family-like. Let me show you what I got going on here. What it is, it's a heavy-duty table. They're going to stack probably 1,000 pounds of steel at a time on it in sheet metal. It's got to be 32 inches from the ground to the top of the table. Yeah. So we're going to go over the materials I'm using and what I've got put together in this weldment so far. Alright, so this is what we got so far. We got two legs sticking up in the air. I got these squared this way. They still have some movement to that way once I get this cross bar that's missing filled in, and then I can tweak them a little. So I got them square off of this leg. I'll square them up off of this leg. Close doesn't count. You really want this as accurate as possible. This is 10 gauge sheet metal here. It's almost point of being considered plate steel. 10 gauge or 3/16 on the 2x2. I think it's 3/16. 10 gauge on my 1.5" by 3. Way more than we need, but we know it's not going to fail. This is really good material, all-purpose material to work with. We use it on a lot of things. So if I got extra, whatever. I actually intended to use 14 gauge for these tubes, and something got screwed up when I ordered, and they loaded me up with 10 gauge. Charged me for 10 gauge too, but so what? I don't have anything welded in the middle yet. What I'll do is I'll get this over on its wheels. One of the last things I do, get this over on its wheels, and I'll weld. I'm going about every foot or so, like a 2-inch spot weld around the perimeter. And I'll do the same on these purlins. Just one side is all it needs. Keep everything nice and straight and level. Somebody may want to forego and do a solid weld the whole way. One, it's wasting a lot of material and a lot of gas, a lot of time. Two, you'll warp your steel and it actually weakens it. So there you go. At this point, I got to make plates that fit down over this with holes drilled in them. Why are there holes drilled in them, boss? Holes are drilled in them for this. DOM, drawn over mandrel is what this is called. Now I'm going to roll this around. You look at it. There's no electro weld line. There's no burr on the inside. This tubing is precisely 7/8 of an inch interior, and I believe it's 1.25 inch exterior, precisely. What makes this special is most tubing, I'll go with one of the legs, one of the square legs. Most tubing, if you roll it over, you can find the electro weld. This started off as sheet metal. Then it was round and electro welded, and then it was drawn through a die to make it square. It's got relative thickness, relative dimension. The exterior is accurate, but the interior is not. And you've got a burr right there where the electro weld was. Square tubing always starts off round. Okay. Now this didn't start off as sheet metal. They got folded and electro welded. This started off as a solid bar stock. And they had an interior die and an exterior die that they shot this through like a Play-Doh extruder. And it made precisely 7/8 interior, 1.25 inch exterior. Drawn over mandrel is about $20 a running foot at this size. That's what makes drawn over mandrel so special. DOM. Bushing stock is also what it's called. What happens is this. I've got the wheels for the table, okay? Well, it's got to have something for that keeper ring to catch. I haven't deburred these since we cut them, so this might present some issue one-handed. There we go. Where I'm at right now is I've got to get a piece of steel to cap this. I'm going to use a 1/4 inch steel I've got, I've only got to make 4 caps, so there was no sense on specifically getting 1 3/4 or 2 inch. For this being 2 by 2, I would get 1 3/4 and I would cut it at 1 3/4. Anyhow, I'm going to drill the holes, weld these on, and then I'm going to cut it off. If that makes sense. What that does gives me enough material that I can square these up well. I don't want them cockeyed in there. I want them as straight as possible. So that being stated, and by the way, this table's upside down. I will weld a hook onto it, snatch it up with the cherry picker, flip it over. Cherry picker's back there. Well, I don't know if this old bit of my uncle's is going to work, but this is the right size. This is what I need, roughly, more or less. It's going to give me enough that I can slide the caster through. We may run into an issue, we need bushings underneath, I don't know yet. But what I did is I marked it, so all I gotta do is cut waste off of this side of this piece and cut it to length. Then I'll mark the others, and I'm not gonna mark them like perfect. Like this one has to be so far, and then I cut it and there's no waste. There's gonna be all kinds of waste off of this piece. But I want this piece whole so I can square these up as I weld them on. So let's see if this is going to do the trick. It looks a little shaky to me, folks. Yeah. Looks like that bit's about fried. What it is, the shaft on the bit where you chuck it up, it is gnarled up and fucked up. I'm going to have to cut that off and get down to the good stuff. Or might be able to take it down to the machine shop and have them true it up, because I don't have a lathe. But with a lathe you can true that up. So we're going to figure this out. I'll be back as we progress on shop table. Alright, so we're back. I went ahead and drilled that hole out. Sent into that bushing stock, DOM, drawn over mandrel. Inside that, at that hole, and I welded around it. Okay, I got good penetration, I burned through, it's all sturdy. Now what I got to do is cut it to fit, and I may have to dress some of this weld so it fits down inside the tube. I want it, there we go, I want it like that. You know, I want to leave a lip that I can put a weld on. And I can't that way, so I'm hitting on that weld right there. That gives us a sturdy mount to post mount the wheels, the casters. And so with that, I'll go ahead and drill 3 more holes in that same stock. Let me kind of show you what I ended up dealing with over here, because that was off center. There was enough throw. I actually shoved it all the way up and got to some good mandrel on that bit, or whatever the hell it's called. But I got some good material that was still squared up to the bit. You know, that bit I'm sure is older than I am. Maybe as old as Jerry over there. It's an old drill bit. But it dogged right through this with some oil. Drill progressive holes. I drilled 1 fucking hole. I don't have a punch. Punch would have made that nice. Hydraulic, you know, press punch. That's where we're at. Alright, so I told you the table, it wasn't a how-to, it's a what we're doing. I zoomed through and I got it mashed out, okay? Time constraints and everything else going on. So let's check this shit out. 4 by 8 roughly. These sheets are actually bigger than 4 foot by 8 foot. There we go. These sheets are bigger than 4 foot by 8 foot, so I cut the pieces to fit, and they're not exactly square or straight. But I got 1.5 inch by 3 inch box tubing, 2 by 2, and those are both 10 gauge. 1/8 inch, 1 3/4 angle iron for the bottom. They can slide their sheets. This is for an HVAC company. so they can slide all their scraps down underneath. They'll probably fit one full piece down underneath there, so they can just throw everything underneath it. If you'll look, see those middle purlins or braces underneath the sheet, underneath the leg. That's bowed a little bit, that's bowed a little bit. That bow will work itself out. I wound up making caps, and up inside that leg is a piece of DOM that fits that wheel. So those, you can pick the table up, the wheels won't fall out. Moral of the story. We've got some bracing up underneath. I got it flipped over, got weight on it, and I welded to that purlin and that purlin to keep the tabletop from being floppy ever. It's a real basic construction. But it's a good workbench. It's a good sturdy work table. Fuck, you could build hot rod chassis on a table this size. Realistically, it overhang. You'd want to make it out of like a 5x10 or a 5x12, preferably. But this would work. I think it's the first time we ever had a sheet of goods come in that I didn't cut up into little tiny pieces for something else. I just kind of want to pop in, show you what's going on. You know, you can see where I've spot welded. That's where the purlin is. I've spot welded on the inside. It keeps that top from flopping around and creating problems. I welded around these and I finished flat to the table. That's all I was worried about, is making a smooth, flat table surface. It's that simple. Wow, made it to the end of the video. Thanks for checking in. Come back on the next one. See what the hell we're up to next time. Subscribe, comment. Find us on over on the old Facebook, Smith Welding Restoration LLC on Facebook. Numbers at the beginning. Have any questions? Call.